Hi, everybody. Tommy Clayton here, an OpenSciEd middle school teacher and lesson writer. Excited to dig into lesson 6. This is a really cool lesson because this is the moment in our lesson set that we've figured out a lot of stuff and we can kind of put it together and apply our thinking to a different device. I think it's really satisfying for the kids to see how far they've come, but also it really opens up an area that we have a lot to figure out. And so the end of this lesson is pretty cool for us to think about, like, the gaps and those type of things. So let's dig in. Let's see how it all unfolds. All right, so let's remind ourselves how we got here. So in lesson 5, we explored the simulation and we introduced an additional permanent magnet or coil, and we saw that the field has a particular shape, and depending on the orientation, if things are attracting, those lines sort of point to one another and seem to connect, and if it's repelling, they seem to curve away from one another in the middle. So in this lesson, we're really wondering, like, how can we use all of this to explain what's happening with the magnet and the coil and the speaker. So let's take a look at this lesson at a glance. This is putting the pieces together, problematizing lesson. So like I said, we're going to put a whole bunch of stuff together, but we're going to puzzle over some interesting things. It's going to take us about 3 days. Not a lot of prep here. It should take you about 10 minutes. No hands-on investigations. Devices are not needed for the students, and there are no additional related videos. All right. So this lesson across the multiple days has several chunks that sort of break down. And so in this first chunk, in the first day, we figure out basically that we figured out a lot of stuff about permanent magnets and electromagnets, the coils. And so we develop a whole bunch of cause and effect relationships, and we make some models in our small group. And then that sets us up to want to do this in a larger space. And so the next chunk is going to happen at the end of day 1 and lead us into day 2. And so that's where we're going to compare our models in a gallery walk, and then we're going to come together and put everything that we figured out into a consensus model in our scientist circle. And then on day 3, we're going to have that assessment, and then we're going to have some time to identify some of the gaps in what we have figured out about the speaker. So in that second chunk, we figure out essentially that changing the orientation of the poles, that's how we get our pushes and our pulls. And when we take the assessment, we figure out that a doorbell kind of is very similar to the speaker, has a lot of the same parts, same things happening in terms of how to get those forces going. And so in that last chunk on day 3, we are puzzling over what's happening with the wire. We think maybe something is in there because we know that the poles or the magnetic field has to flip somehow. And so we're like really unsure how that's happening. So it's going to lead us into our next lesson. So ultimately, what we figure out in this lesson is that we can put everything together. So this is the culmination of all of the things that we've been figuring out for the last 5 lessons. And essentially, we've at this point figured out how we are getting these forces and how those forces can be manipulated so that we get pushes or pulls to make that speaker move back and forth. So let's take a look at some of the key moments. All right, so in part 2, after we navigate in, we are going to develop a huge list of our cause and effects. So like all the things that we've been thinking about and figuring out from lesson 2, lesson 4, and lesson 5, and we're going to put these all together on a chart. And try to really help students think back to the previous investigations, but stay focused on what's going to help us explain how the speaker works, okay? And the how and the why part can be tricky for students, and that's because a lot of the answers to this is about the field, and this is the part that they can't see and is sort of abstract. So when we think about the how and the how and the why, help students to really focus on like what might be happening with the magnetic field, and describing those different parts. And that's okay, because this motivates us to actually want to draw it. So it's okay if it's hard to put into words, kind of like own that with the students and say, I think maybe what could be really good is to draw some of these ideas, and we're going to do that next. So, like I said, the kids will draw the model, then we'll come together, they'll do a gallery walk, and then that puts us into this positioned to build a consensus model in the scientist circle. And this is like in day 2. So thinking about this 3-day lesson, this is like the halfway point. And so students are going to come together to draw this model. We want to make sure we start by drawing what is happening when nothing is plugged in with the coil and the permanent magnet is sort of sitting there. Like, we want to first talk about the system before we make any changes. And then we're going to think about the 2 different orientations. So we want to draw one with the magnets having this south-south or north-north orientation. And then we want to consider the other one where we set it up to be north-south. Just like we did in the previous models, we want to use those little compass arrows conventions from the interactive to show the direction of the field. And we want to make sure that we're including cause and effect statements as we talk about all of these. This is something that students are going to do on the assessment later on. So we want to help them practice that, and it gives you a chance to check in with them on that. Then part 7 is the assessment. So this is the start of day 3. And this is where they're going to take that assessment about figuring out the doorbell. First, they're going to write some cause and effect statements, and then they're going to do a little bit of modeling to explain how the striker can actually move and hit the bell. And you'll notice it has the coil and all that good stuff, just very similar to what we've been doing. But again, we're applying it to something a little bit different from what we've seen before. Then after that, we are going to really identify the gaps. So we're trying to figure out, like, what is different about the speaker when it's plugged in? What's causing the flip in the orientation? And like, what might be happening in the wire? Like, what's happening with this whole other part of the system with the music player and the wire? And that's really like where we want to kind of go next to try to figure out more about what's happening. So where we go from here is to start to shift to an energy perspective. We've been talking a lot about forces. And so we're going to shift to an energy perspective to really investigate what might be happening in terms of the energy that's transferring in and out of the field. And so we're going to do some investigations around that in the next lesson. So here's some tips and tricks for this lesson. When you are working with students on building that consensus model, it's very likely that they're going to start to identify some of those gaps that we do after the assessment. Try to focus them back on the pushes and pulls. They're going to be really still wondering about, like, what is causing the magnetic field to flip around so we can get pushes and pulls, and try to help them just focus on what we currently know. And it's okay to, take a moment, have kids write those on the questions and put them on the question board, because we're going to come back to that later, after the assessment. So try to just, get them focused on just the parts that we have evidence for at this moment. As I spoke about earlier, that convention of arrows from the interactive is helpful, but if you have a different convention to show the direction of the field, that's fine. Just try to keep it consistent throughout the modeling you do with the kids. And I find it really helpful to have props during this. So having a coil ready to go, having a magnet ready to go to hold up, to talk through with the kids, to maybe even have them manipulate themselves. So in the assessment, a couple of really important things. One is it's really helpful for the students to see the doorbell. If you have the physical one in the kit, that's great. Or a video of it, something that they can just actually see it. I think a lot of kids think of a doorbell as like a Ring camera now, and this might not be super familiar to them. So really just getting them familiar with that. Focus students on just the hammer hitting the bell one time. We don't need students to model the back and forth motion. We just really need them to model how the hammer gets pulled toward the bell and hits it. So really just focus them on that one motion, that one moment in time. There is nothing they are going to draw on the left side. That can be kind of confusing for students because they probably feel like, I actually need to draw something. But by design, there shouldn't be anything that they're drawing there. The field around the coil is going to be a little bit messy, and that's okay, because drawing fields around coils can be a little bit tricky. They should have practiced this before, but that part you might want to give students a little bit more support around. There are no new words that we are going to add to this lesson, to our word wall. We do have some posters happening. So we have that forces at a distance consensus model. You're going to want to keep that because we're going to add to it later on. And this cause and effect tracker, we are going to add to this as well. So you're going to want to keep both of these. You're going to need them for later lessons because we're going to add some new, cool, exciting stuff to them as we figure things out. So that's going to do it for lesson 6. I hope you found it helpful to see how the moments lead up to the assessment. And I think you're really going to enjoy watching the students sort of put it all together and then really get puzzled at the end when they realize there is still some gaps in the model that they need to figure out. Come back and join us for lesson 7, and we'll see how we set up getting into the energy lens of the unit. Thanks, everybody.